Okay, so let's look at some of the computational techniques of limits. So let's suppose that the limit of f of x as x approaches a exists, and the same for g of x, it exists. Okay, and c here is a constant. So addition and subtraction. So basically, the sum of two functions, if you take a limit, it equals to, well, when you separate them, yeah, you can separate them. Okay, that's basically addition. So for example, here, if I take the limit of this function x cubed plus 4x as x approaches 3, let me do without separating them first. So since they have a value at x equals 3, I can just plug them in. So this will be 27 plus 4 times 3, which is 12. Okay, so all of these combined, we will get a 39. Okay, what about when we separate them? So this equal to the limit as x approaches 3, x cubed plus the limit as x approaches 3, 4x, which equal to, well, coincidentally, 27, 3 cubed, 27, plus 4 times 3, which is 12. Then they give us the same answer, 39. So this is basically the addition of limits. You add the two functions together, and then you take the limits of it. It's the same as you taking the limits first, then adding them up. It's the same thing. Then later, subtraction. So subtraction, you can think of it as adding a negative, right? So instead of, let's say, 3 minus 9, you can think of it as 3 plus negative 9. It's the same thing. It's the same thing as addition, basically. So it's the same. You can separate them. Like, you can take the limit first, or you can take the limit later after subtraction of the function, or you can take the limit first and then subtract the two individual values. Okay, so for example, let me compute them first. Let's say, okay, the function x cubed minus 4x, it is continuous, like it has a value when x approaches 3. So we can just plug x equals 3 inside, which is 27 minus 12. Then we get 15. Okay, but then let's separate them first. So we can get limit as x approaches 3, x cubed minus the limit as x approaches 3, 4x. Then we plug x equals 3 inside. Then we get 27 minus 12, which is the same thing, 15. Okay? Later on, let's look at multiplication and division. So multiplication, let's say a constant times a function, right? The constant times a function is the same, like if you take a limit of it, it's the same as you pulling the constant out and then taking the limit of the function, right? So for example, let's say I have this function. Then what do we get? So firstly, well, we can do the addition first. So we will get the limit as x approaches 2, 4x to the power of 5, plus the limit as x approaches 2, 3 over x. Then without pulling the constant out, we just put the values inside. Then we get 2 to the power of 5, 32, 32 times 4, 128, right? Yes, 128, plus 3 over 2. Yeah, and then this gives us 129 and a half. Okay. But what if we pull the constant out first? So in this part, we can do 4 times the limit as x approaches 2, x to the power 5, plus 3 times the limit as x approaches 2, 1 over x. Then we get 4 times 32, which is the same thing as 128, plus 3 times 1 over 2, which is 3 over 2. Then we get the same answer, 129 and a half. Okay, that's basically if a constant multiplied with a function. Okay, we can just pull the constant out, right? Later on, function times a function. Well, if I have a function multiplied by another function, and then we take the limit of it, it's the same thing as taking the limit first, then multiplying them. So, for example, the limit as x approaches 3 of this function, let's now separate them first. So, since it has a value, like you can just plug x equals 3 in, then you just plug x equals 3 in. So we get 2 times 3, which is 6, 6 minus 3, which is 3, so 3 times 3 squared, 9, minus 6 times 3, 18, plus 9, which is 0, so the answer is 0 here. Okay, but what if we separate them first? So I can make this into the limit as x approaches 3, 2x minus 3 multiplied by limit as x approaches 3, x squared minus 6x plus 9. Okay, then after separating them, we just take the limit of the two functions. Then again, 6 minus 3, which is 3, and the right hand side we get x squared, 3 squared minus 6x plus 9, which is again 0 times 0, so which is 0, and they reach the same value. Okay, so for a function multiplied by a function, you can just take the limit first, or you can take the limit later after multiplication. It doesn't matter. It depends on whether you think it's convenient or not. You can choose whenever to do it. It doesn't really matter. Okay, then. So for the special case, let's say my g of x equals to f of x. Alright, if I have a lot of f of x multiplied together, so which means that it's f of x to the power of n, is equal to you taking the limit of the inside first, and then take the exponent, like take the power to the, well, take to the power of n later. It's the same thing. So for example, when n equals 2, so limit as x approaches a, so when n equals 2, it means f of x squared, which is 2 times of f of x, right? And from the multiplication thing, well, from the quality, we can do limit as x approaches a, f of x, times limit as x approaches a, f of x, which is the limit as x approaches a, f of x, the whole thing squared. Alright? And from then on, you can see, oh, to the power of n, it's the same thing. Alright? And now, let's look at division. So, it's the same, it's basically the same concept as multiplication, addition, and subtraction. It's just like multiplication and division. Okay, it's like multiplying with the what's that called? Like the 1 over something. I forgot that phrase. Well, it's basically the same thing. So either you do the division first and then take the limit. It's the same thing as you taking the limit, then do the division. So for example, I have the limit of this function divided, well, not divided, well x approaches 4. So before multiplying, let's just see, okay, So if we plug 4 in, we reach a value that's continuous. It's not like there is a value. So we can just plug in x equals 4, which gives us 3 times 16, which is 48. 48 minus 5, 43. And then on the denominator, we get 4 to the power of 3, which is 64, because 16 times 4 is 64. 64 times 4, which gives us 256 plus 1. Then we get 257. Okay? But then what if we take the limit first? So then it will become limit as x approaches 4, 3x squared minus 5 over my limit as x approaches 4, 4x cubed plus 1. Then we get, from the numerator, we get 16 times 3, which is 48. 48 minus 5, 43, same thing. And then the denominator, 4 to the power of 4, which is 16 times 16, which is 256. 256 plus 1, which is our 257. They reach the same value. So this is our division and multiplication. Like, they reach the same value, even if we take the limit first or later. Okay, it doesn't really matter. And then for this case, which is if you take the not absolute value, if you take the square root of the function first, it equals to you taking the square root after. So it doesn't matter whether you do the limit first or not. So for example, whoa, I didn't write an example here. So let's do it right now. Example. So I have the limit. Let's say x approaches 2, square root of x squared minus 3, x squared minus 3. Okay, then let's not take the limit first. Well, let's not take the, what am I saying? Yeah, let's not take the limit first. So we can just see for this function, we can plug in 2 inside. So we get square root of 4 minus 3, which is square root of 1, which is 1. Or we can take the square root later. So it's x squared minus 3, then we take the square root later. Then we get the square root of, when we plug 2 in, 2 squared is 4, 4 minus 3 is 1, so the square root of 1, which is same thing, 1. Okay, so these are like the few computational techniques. It's like basic, like adding and subtracting, multiplying and dividing. It's the same operation whether you take the limit first or you take the limit later. Okay, so for next video we'll be covering other computational techniques. So I'll see you then. Bye bye.